Section 1.6, Amazon Aurora's Scalability Overview. First of all, I can't take credit for this picture. It comes from a very funny slideshow by John Newton, founder and CEO of Alfresco. The slideshow is very entertaining, yet very technical, and can be found at the link on the screen. The slideshow is a use case for Amazon Aurora's scaling, entitled Scaling Massive Content Stores with Amazon Aurora. So in this section, we're going to talk about Amazon Aurora's scaling, baby. The minimum storage capacity for an Amazon Aurora cluster is 10 gigabytes. Based on your usage, your storage will automatically grow in 10 gigabyte increments up to 64 terabytes with no impact to database performance and no need to provision this storage increase in advance. You can scale compute resources allocated to your instance in the AWS console. The associated memory and CPU resources are modified by changing your instance class. Requested changes can be applied during your scheduled maintenance window, or you can flag it to be applied immediately. Either way, there will be an availability impact for a few minutes while the scaling operation is performed. You can scale from an instance with 2 vCPUs with 15 gigabytes of memory to an instance with 32 vCPUs and 244 gigabytes of memory. And you can add up to 15 low latency read replicas spread across 3 availability zones to further scale read capacity. This screenshot shows where you set your maintenance window. If you select no preference, the time period will be random. If you choose select window, the day and time choices appear pointed to with the red arrow. With Amazon Aurora, you have the option of scaling up by using a larger instance type or scaling out using Aurora read replicas. As demand grows for your application, you can scale up your instances by upgrading to a larger instance type. For example, from a DB-R3 large instance type with 2 vCPUs and 15 gigabytes of RAM to a DB-R3 8X large instance type with 32 vCPUs and 244 gigabytes of RAM. The computation and memory capacity of a database instance is determined by the instance class, and you choose which instance type you need depending on your requirements. As of September 2016, there are 3 families of instance types. Amazon Aurora can only use memory-optimized DB-R3 instances that provide memory optimization and more compute capacity than the first generation DB-M2 instance classes that you see on the top row. And you don't need burst-capable instances, as you see in the lower row, because Amazon Aurora automatically scales for you, and therefore it's not supported for Aurora. In the Aurora console, you select the instance that you want to scale up, then from the Instance Actions drop-down, choose Modify, highlighted here. Then select the new instance type and either apply immediately, seen in this third screenshot, or it'll happen during your next maintenance window. You can scale out by adding up to 15 read-only Aurora replicas. You configure your application to send read-write traffic to the primary instance and read-only traffic to the replicas. You can see in the screenshot the primary instance has a red rectangle around it, and the replica has a blue rectangle around it. And in all the green rectangles, you can see that the primary instance is write and read, and the replica is only a reader. To configure read replicas for your Aurora cluster, in the Aurora console, select your instance, then from the Instance Actions drop-down, choose Create Aurora Replica, highlighted here in the drop-down. Then select the instance type, a value for the DB instance identifier, and choose Create Aurora Replica. This concludes section 1.6. Amazon Aurora's Scalability Overview. Coming up next is Section 1.7, Amazon Aurora's High Availability and Durability Overview. Section 1.6, Amazon Aurora's High Availability and Durability Overview. I credit this image to a company called Alfresco, mentioned previously. Alfresco uses AWS services for enterprise content management and business process management at massive scale. The URL to their business is in the image courtesy disclaimer on the bottom right. Looking at the differences in the architectural diagrams of MySQL with Standby versus Amazon Aurora, you'll notice the following differences. In MySQL with Standby, in Availability Zone 1 is the primary instance, and in Availability Zone 2 is the Standby instance. There's synchronous replication between these two instances, noted by the many colored arrows between them. Both of them use sequential writes to the elastic block store using mirrors, and only the primary instance backs up to Amazon S3 for point-in-time recovery is done sequentially, where a DBA can then restore the database from backups. In Amazon Aurora, in Availability Zone 1, it has the primary instance, and Availability Zone 2 has a replica instance. Synchronization between the primary instance and the replica instance is asynchronous, noted by the one purple arrow between them. Writes to the logging and storage layer is asynchronous using Quorum for distributed systems, and backups to Amazon S3 are distributed using all of the replicas and storage blocks. Each 10 gigabyte chunk of your database volume is replicated 6 ways across 3 availability zones and continually backed up to Amazon S3. You can create up to 15 read replicas that upon instance failure, the relational database service multi-availability zone technology automates failover to one of the replicas. If a failure occurs and no replicas have been provisioned, Amazon RDS will attempt to create a new Aurora instance automatically. Amazon RDS continually monitors the health of your Amazon Aurora database and the underlying EC2 instance. If the database fails, Amazon RDS will automatically restart the database and associated processes. Talking about storage node availability and durability, Amazon Aurora implements a technique called Quorum that enforces consistent operation in a distributed system. It's used as a replica control method and a way to ensure transaction atomicity in the presence of network partitioning. The Quorum membership changes do not stall writes. Peer-to-peer gossip replication fills in the holes. The gossip protocol discovers and shares location and state information about the other nodes in the cluster and is persisted locally by each node. This has been likened to gossip around a water cooler, whereby at the end of the day, everyone has heard the latest gossip at least once, if not many times. Amazon Aurora has continuous scrubbing of data blocks. Data scrubbing is an error correction technique that uses a background task to periodically inspect main memory or storage for errors, then correct the detected errors using redundant data in the form of checksums. This reduces the likelihood that a single correctable error will not accumulate. Amazon Aurora's backup capability enables point-in-time recovery of your database instance to any second during your established retention period up to the last 5 minutes. Your automatic retention period can be anywhere up to 35 days. As you can see in this screenshot, although it's not scrolled all the way down. Automatic backups are stored in Amazon S3, which is designed for the 99.949% durability. These backups are automatic, incremental, and continuous, and have no impact on database performance. Amazon Aurora's storage is fault tolerant, transparently handling the loss of up to 2 copies of data without affecting database write availability, and up to 3 copies without affecting read availability. Amazon Aurora has automatic detection, replication, and repair of storage nodes. Amazon Aurora isolates the buffer cache from the database process, allowing the cache to survive a database restart in less than 30 seconds and with near instant crash recovery. In the case of a crash, Amazon Aurora will result in redo logs being applied to each segmentation on demand in parallel and asynchronously. Database snapshots are user-initiated backups of your instance that are stored in Amazon S3 until you explicitly delete them. They leverage the automated incremental snapshot technology to reduce the time and storage required. You can create a new instance from a database snapshot whenever you want to. This concludes section 1.7, Amazon Aurora's High Availability and Durability Overview. Coming up next is section 1.8, Amazon Aurora's Security Overview.